17.2, complete ionic equations. Got a problem here. We want to write a balanced equation, the complete ionic equation, and the net ionic equation, and then identify what the spectators are. In order to do this, we need a solubility rules table, and we can find one of those on page 574 in our book. So first thing I want to do is write down my equation, sodium phosphate, 1 plus 3 minus, so Na3PO4. That is aqueous. Reacts with aqueous barium chloride. Well, 2 plus 1 minus becomes BaCl2, and that is aqueous. To form, if it's double replacement, it must be barium phosphate and sodium chloride. 1 plus 1 minus, so that's correct. 2 plus 3 minus, so it's Ba3PO4 2. From the solubility rules table on page 574, we need to figure out which of these products is the precipitate and which one is aqueous. Well, if I look to try and find these ions, I see phosphate in rule number 8, which means it is insoluble unless it's with a rule 1, which is an alkali metal. Barium is not, so that must be the solid. If I look at the other one, sodium chloride, well, sodium is rule 1, and actually chloride is rule 4, both of which let me know that sodium chloride is aqueous. From my equation, I now just need to balance it. Looks like I need 2 there for my phosphates. I need to put 6 there for my sodiums, 3 barium chloride for my chlorides, and I have 3 barium. So I've got my balanced equation done. To write the complete ionic equation, all you do is simply break apart anything that is an ion and write it as such. So everything aqueous you want to write as ions. This first one is aqueous, so I really have 2 times 3, 6 Na plus aqueous ions, and I have 2 phosphate 3 minus ions. I have 3 barium 2 plus ions and 6 chloride ions. Over here, the barium phosphate was a solid, so that will not split apart, but the salt is aqueous, so it will split apart. That would be the complete ionic equation, taking everything that is aqueous and splitting it apart into ions. The net ionic equation really shows you what is reacting. So to find the net ionic equation, all you have to do is get rid of your spectator ions. And spectators, like spectators in a ball game, do nothing. They don't change at all. They just sit and watch. So look and see if you have the same thing on both sides. Those would be your spectators. Well, the 6 sodiums appear on both sides. You've got 6 chlorides on both sides. And what you're left with, 2 phosphate ions, aqueous, and 3 barium ions, aqueous, producing 1 barium phosphate solid. That would be your net ionic equation. I'll let you try one more here. Sodium hydroxide, aqueous, reacts with aluminum chloride. Don't forget to cross your charges. This must produce sodium chloride, and that is aqueous by rule number 1 and or 3, and aluminum hydroxide, 3 plus 1 minus, and according to rule number 10, aluminum hydroxide is the solid. If we balance this, looks like I need 3 in front of the sodium hydroxide for my hydroxides, 3 sodium chlorides, and now we're balanced. To write a complete ionic equation, separate everything that is aqueous into ions. And it looks like the aluminum hydroxide is the only thing that doesn't get separated because that was a solid. From that, we're going to circle the things that don't change. I got 3 sodiums on both sides. I have 3 chlorides on both sides. What I'm left with is my net ionic equation, which looks like 3 hydroxides aqueous plus 1 aluminum aqueous produces 1 aluminum hydroxide solid. So you simply have to find the solid in the balanced equation right there, and the ions that react to form it will give you the net ionic equation.